The scent of pine tar and salt spray filled the air, thick with anticipation. Before them lay a behemoth, a fully constructed longship, perhaps 30 meters long. Its oak timbers gleamed, a vessel capable of traversing oceans. Its weight, an estimated 30 tons, seemed an insurmountable obstacle. No cranes, no hydraulic lifts, only the raw ingenuity and collective strength of the Norsemen. This was the culmination of months of meticulous labor, a testament to an entire community's skill. Failure to launch meant wasted resources, a lost season of trade or raiding, and a blow to the village's prestige. The problem was monumental: how to transition this vast wooden hull from the land where it was born to the water that was its destiny, using only rudimentary tools and muscle. The chosen launch site was paramount. Often a natural incline leading directly to the water's edge was selected, minimizing the distance the ship needed to travel. The ground was carefully prepared, cleared of stones and debris, then compacted to form a stable, gentle slope, a primitive slipway designed to guide the colossal vessel towards its element. At the heart of their mechanical advantage lay simple, yet effective technology: rollers. These were typically sturdy logs, perhaps 20 to 30 centimeters in diameter, made from resilient hardwood. Placed perpendicular to the ship's keel, these rollers created a rolling friction surface, transforming static weight into manageable forward motion. To move the ship, a complex system of ropes and levers was employed. Ropes meticulously crafted from twisted animal hides or strong plant fibers were anchored to the ship and secured to fixed points or pulled by teams of people. Robust wooden levers, used to incrementally nudge the ship forward, provided crucial mechanical leverage, amplifying human force. The launch was a communal event, demanding absolute coordination and synchronized effort. Every able-bodied adult, from Jarl to Carl, had a role. The rhythmic chanting of commands, the straining of muscles, and the precise timing of each push and pull were essential to prevent the immense vessel from veering off course or becoming hopelessly stuck. Friction, the silent enemy of every launch, was mitigated through lubrication. Animal fats, often rendered from pigs or seals, or even fish oil, were generously applied to the slipway and the rollers. This greasy layer drastically reduced resistance, allowing the massive hull to glide more smoothly with each coordinated heave and push. The longship itself was engineered for this challenge. Its shallow draft and relatively flat bottom, characteristic of Viking vessels, allowed it to float in surprisingly shallow water. This design reduced the distance it needed to travel on land and eased the final transition from rollers to buoyancy, minimizing the risk of grounding. The keel, the backbone of the ship, was exceptionally strong. Built to withstand the immense pressure of launch, it distributed the ship's weight evenly across the rollers, preventing structural damage during the stresses of movement. This foundational timber was a masterpiece of Norse shipbuilding, designed for both sea and shore. Beyond the physical mechanics, the how also encompassed the deep understanding of natural forces. The Vikings often timed their launches with high tides, allowing the rising water to meet the ship as it neared the end of the slipway. This natural lift significantly reduced the final effort required, floating the vessel off the last rollers with minimal strain. This communal effort was more than just brute force. It was a deeply ingrained social mechanism. The construction and launch of a longship bound the community together. Every individual contribution, from felling trees to twisting ropes, fostered a sense of shared ownership and collective responsibility for the success of the endeavor. The Jarl, or local chieftain, often oversaw these complex operations, his authority ensuring discipline and coordination among the large workforce. His presence was not just symbolic. He possessed the knowledge and experience to direct hundreds of men and women, ensuring the meticulous execution of each stage of the launch process. Specialized teams managed specific tasks. One group laid and retrieved rollers from the rear, moving them to the front as the ship progressed. Another applied lubricants, while others manned the ropes and levers. This division of labor, though seemingly simple, was a highly efficient system for orchestrating a task of this magnitude. Compared to their contemporaries, the Viking method of ship launching showcased a unique blend of engineering and community organization. While Roman or Byzantine engineers often relied on complex scaffolding, winches, and even dry docks, the Norse approach was lean, efficient, and adaptable, requiring fewer specialized tools but greater collective muscle. In other parts of Europe, larger ships were often built in specialized shipyards with permanent structures. The Vikings, however, often constructed their vessels closer to the water's edge, sometimes even in temporary clearings. This mobility meant they could establish shipbuilding operations wherever suitable timber and a good launch site were available. The focus on horizontal movement over vertical lifting distinguished the Norse approach. While Saxon or Frankish shipbuilders might have struggled with the sheer scale of a longship using their existing technologies, the Viking reliance on rollers and incline minimized the need for complex leverage systems, simplifying the physics of the operation. The efficiency of their methods allowed for rapid ship production, a critical factor in their expansion. While other cultures might spend years on a single large vessel, the communal and streamlined Viking process meant new ships could be launched with impressive frequency, fueling their voyages of trade, exploration, and conquest. This ability to efficiently launch large vessels contributed directly to their strategic advantage. It allowed them to project power and influence across vast distances, appearing with fully manned fleets in unexpected locations, leaving other European powers often unprepared for their sudden arrival. The practicality extended to the materials themselves. Using readily available hardwoods for rollers and animal byproducts for lubrication showcased their resourcefulness. They did not require imported iron or specialized machinery. Their system relied on what the immediate environment provided, maximizing self-sufficiency. This contrasts sharply with the logistical challenges faced by empires maintaining large naval forces, which often required centralized infrastructure and extensive supply chains. The decentralized, community-driven shipbuilding and launching of the Vikings was a more organic and arguably more resilient system. The era of the independent Viking longship, launched by collective might, did not last indefinitely. The very success of the Norse expansion eventually sowed the seeds of its transformation. The decentralized structure, which allowed for swift ship construction and launch, began to wane with profound shifts in Norse society itself. The advent of Christianity across Scandinavia brought an end to the pagan social structures that underpinned many Viking activities. With new religious institutions came new forms of social organization and authority. The emphasis shifted from individual glory and raiding to settled kingdoms and more centralized control, affecting how and why ships were built. The rise of powerful kings and consolidated nations across Scandinavia gradually replaced the autonomous local chieftains. These new monarchies began to establish formal navies, utilizing more standardized shipbuilding practices and often permanent shipyards. The need for spontaneous community-driven ship launches decreased as state-sponsored infrastructure grew. Trade routes became more formalized, and the nature of maritime commerce evolved. While Viking ships excelled at opportunistic raiding and long-distance exploration, the demand shifted towards larger, dedicated cargo vessels and specialized warships for state-on-state conflicts, altering design and construction priorities. Furthermore, environmental pressures likely played a role. The continuous demand for high-quality oak and pine for shipbuilding could have led to localized deforestation in some areas, making large-scale timber procurement more challenging and driving construction towards established, resource-rich centers. As the Viking Age concluded, the innovative construction and launching methods were not entirely lost. Many techniques, particularly clinker building and the use of rollers, were absorbed and adapted by later European shipbuilders. However, the unique, communal, and often temporary nature of the Viking launch faded, replaced by more industrial approaches. The practical logic of moving a massive hull without modern machinery persisted in coastal communities for centuries, albeit on a smaller scale or for repairs. The specific cultural context that made the 30-ton longship launch a regular collective ritual, however, dissolved into the historical record, a testament to a bygone era. The Viking method of launching a 30-ton ship without machinery was not merely a feat of engineering. It was a profound expression of communal resilience and ingenious pragmatism. It represented a society that leveraged collective strength, deep understanding of natural physics, and readily available resources to achieve what, by modern standards, appears impossible. The rhythmic creak of oak timbers and the coordinated shouts of hundreds as a longship slid into the water were echoes of a mechanical history built on observation, adaptation, and an unwavering commitment to a shared goal. It highlights how complex problems were solved not through advanced tools, but through applied logic and organizational prowess. This legacy of practical ingenuity remains a powerful lesson. It forces us to reconsider the definition of technology itself, broadening it beyond intricate machines to encompass the human systems, the communal effort, and the intimate knowledge of the environment. What other impossible feats of Norse engineering might still surprise us?